So if we're having a look at pipe sizing, first and foremost we're going to need to look at this data table which establishes the pressure loss in millibar across the length of the pipe that we're going to be installing. Down the left hand side we have an input in gross and an input in net. And across, so let's just say, for example, we wanted 15 kilowatt inputs in net. So I went there 15.72 and I went across here and I was thinking of putting 22mm pipe in. So the pressure loss over 1 metre of 22mm pipe will be 0.0268. So that's sort of how we are using the table. Let's have a look what we need to do with it. So I'll begin with a simple setup of pipe which we're applying. So you can see there we've got a metre, we've got 21 millibars of pressure at the metre, then we've got a length of straight pipe, 10 metres long, going to a boiler, 15 kilowatt heat input, and it's 20 millibar. We don't want any pressure drop less than 1 millibar when it gets to the appliance. And you can see in this green box here, I've got it in gross. So here's a little screenshot of the table. So I've got input gross, 15.13. I'm going across here and you can see I've gone for 22mm pipe, 0.0214. So I've got 0.0214 times 10, which is our 10 metres of pipe work, equals 0.214 millibar. So a lot less than 1 millibar drop across that 10 metre length. If I did it in net, you can see input net 15.72, 0.0268, times it by 10, 0.268 pressure drop across that 10 metres. Very, very simple when it's a straight piece. Gets a little bit more complex when we're adding some bends because it's going to form some form of resistance and that has to be taken into account. So let's have a look at it. And now we've got more than one appliance. So we've got our meter. And we've got a 10 meter length across to appliance 1 and some meterage down there. Now, those will change in a moment and I'll explain why. So appliance 1, the pipe is coming from A to B, and then I've circled B because B must be able to carry enough cubic meters of gas and allow enough flow of gas through to service appliance 2 and appliance 1. So the red circle must have enough to supply both appliances. So we've got A to B and then from B to C. Appliance 2 is coming from A to B and then it goes from B to D. So you can see where I've changed the sizes here somewhat, just to simplify. So we've got two appliances, total heat input in kilowatts is 40, so we've got 15 at appliance 1 and 25 at appliance 2. And don't forget we're going from A to B, and then from B to C for that appliance number 1, and appliance number 2, A to B, and then from B to D. So you can see we've got our chart again, and I've circled in pink the ones that correspond with this pink box over here, and green is circled here for the one that corresponds with that. And in the grey boxes are our pressure drops. In the pink boxes is the sum from B to C and B to D, and A to B is in the green. So you can see A to B, for example, well, that's 40 kilowatts because A to B, if we go back, is servicing both appliances. So I've gone 40 kilowatts and it's in green, so it'll be down here somewhere. and we've got 0.036. So if I look, 0.36 is there, and I'm using 28mm pipe, so that tallies up there. And I've got a number 4 there, so if I just go back, you can see A to B is 4 meters long, and I've gone 40 kilowatts because I've got 25 there and I've got 15 there. 40 kilowatts. Multiply them and I've got 0.144 millibar. And you can see there, A to B, 0.144 millibar. Then appliance 2, if we go to appliance 2, A to B, it's still coming from the same thing, so it's going to be exactly the same. Then we go B to C. So if we look here, B to C is doing this one, so it's 15 kilowatts there. I've looked at my 22mm, I've come back to my chart, and that's all you're doing. You're just going backwards and forwards using the chart. It's very straightforward. Excuse me. And then once you've got all that information, you're going to add them all together. So let's have a look over here. Across the whole installation, the total pressure loss will be 0.9 millibar for all of that, so which is less than our 1 millibar that we wanted. So across this installation, when all these sums are taken into account, we've got 0.9 millibar pressure drop. We've done all our sums here. So we've got 1, 2, 3, 4 pieces of information there. So we've got appliance 1, appliance 2, appliance 1, appliance 2, appliance 1, total, and appliance 2, total. So we're adding those two together. These are our 4 pieces of information. 1, 2, 3, 4. Go back. 1, 2, 3, 4. So we've got those two. That's a total pressure drop for appliance 1. And those two, total pressure drop for appliance 2. Added together, the 651 and the 278 is 0.929 millibar. So we can stop recording there, and hopefully that will assist you in beginning to look at pipe sizing. And we're pipe sizing natural gas using copper pipework, using the chart for the pressure loss.